We've now added tuples, we've added lists, we started to see the kinds of things we can do with them, all the sorts of things we like to do. We can slice, we can index, we can mutate the lists, we can apply functions to all of those pieces. We're going to add in one last data structure that is a further generalization of the kinds of things we've been building. And that data structure is a dictionary. So a dictionary is a generalization of a list, but now the indices, the ways to get to elements of the dictionary, don't have to be integers. And if you think about it, a list is a linear sequence of things, and it's indexed starting at 0, 1, 2, 3, all the way up to the end. Now with dictionaries, the places or the ways to get to elements of the dictionary can be any value that's immutable. What does that mean? First of all, we're going to start referring to these indices not as indices because that implies integers, but as keys, because the keys can be arbitrary in form. And a dictionary then is simply a collection of key value pairs. That is a pairing of some key and an associated value. The syntax for this is shown here. We use curly braces to indicate that this is a dictionary. And each of the pairings is a combination of some key, a colon, and some value. They're separated by commas. So the commas tell me where the ends of each one of those are. And so I'm giving the name month numbers to a collection of Jan 1, Feb 2, Mar 3, and 1 Jan, 2 Feb, and 3 Mar. So I've got pairings both ways. Each pairing has both a key and a value in it. Okay, if I've got that, and in fact I'm just going to show you over here, I've got month numbers defined, and it is that pairing of these pieces. Now, what I can do is I can start doing things on this. So the first one is if that's month numbers, one of the first things I can do is I can get out elements of it. So I could say, for example, if I want to get the value associated with a key, I simply give it that name, or that value of the key rather, as an index. And it gives me back the thing I'd like. Or I can say, if I want month numbers of the value associated with the key 2, I can get back that as well. So we get things by giving it a key. This looks a lot like list, except that now the things that go in are arbitrary expressions. They don't have to be integers. It's also important to notice, there's what we can do if we give it a second one, it's important to notice that the entries in a dictionary are unordered, and they can only be accessed by a key, not an index. And in fact, if you look back on my idle screen, you can see when I printed out month numbers, it gave me the dictionary, and notice they weren't in the form that I typed them in. I typed them in with Jan of 1, and yet it has 1 and Jan as being the first element of it. And so if I somehow say, gee, I'd like to get what I think is the 0th entry of month numbers, which would be that 1 Jan pairing, it's going to complain. Because in fact, I can't index by number, I have to index by key. Okay, so what can we do with dictionaries? Well, we can do insertion. So for example, I can go over to month numbers and I can add something new, and I would do that as you might expect. I'm going to give it as an assignment statement saying, associated with the key APR as a string, I want the value 4. And that has now added to the dictionary month number, so that if I ask for the value associated with the key APR, it gives me back 4. So I've just inserted something into there. I can also iterate over a dictionary, and I want to show you an example of this. I'm going to bring this up here. I'm actually going to type it in over here. I'm going to create a variable called collect, which is going to be initially an empty list. And then I am going to loop over this dictionary I created, month numbers. So I'm creating an iterator. E is going to vary over each of the elements of that. And I'm just going to append to the end of collect that entry. And if I now look at what collect is, cool. It's a list. Oh, and notice what it put in. It looks like it has put in the keys associated with each one of these things. And that's actually very good. Okay, so I've got the keys associated with each one. And indeed, if I want to look at this, I can compare that to month numbers of keys. And that's just a method. And we'll come back to methods later on, but basically it's a method associated with the dictionaries, which is going to give back to me the list of all of the keys. And it turns out to be in exactly the same order. Not a big deal. All I wanted you to see was the idea that we can iterate over a dictionary, doing things to the elements if we want to, and that's great. The final thing that we can do is stress that the keys can be complex. I can create a new dictionary where my keys now are tuples. The tuple 1, 2 or the tuple 1, 3 have values associated with them. I can ask for the value by giving it that key. And notice the form. I have to actually give it the key, open paren 1, comma 2, close paren, and it will get back for me the value in the dictionary. It's also important to stress that these keys must be immutable. So I can use a tuple as a key, but not a list. And that makes sense because if I'm storing something with a key and a value and I can somehow go along and change the key, that's going to really mess things up. I can't have mutable keys. They need to be immutable. And this is one place where it's advantageous to have both a tuple that can't change and a list which we can change. This is intended to be just a brief introduction to dictionaries. We'll come back to them and their methods later on. But now what you've seen is we can have arbitrary collections of elements, ordered collections like tuples and lists, and collections like dictionaries that are simply indexed by arbitrary kinds of things. And we've got functions that can start operating on those kinds of data structures. And that's going to add a lot of power to the kinds of things we can do.